Okay, last unit of the year. You can do a wave. Last unit of the year. Okay. We're going to be mixing, not that they go together really well, but we're going to be mixing organic chemistry and nuclear chemistry. Again, they don't go together really well, but of all the components on the AP, these are covered in the least amount. So I'm giving you superficially what you need, and that doesn't really make enough for one unit. That's why I'm putting them together. So today we're going to go over the basic nomenclature for alkanes, alkenes, and alkynes. If you took pre-AP chemistry, you've already done this. If you took regular chemistry, you haven't. You might get a little overwhelmed, but you'll get it. It's not that bad, and there's plenty of people around who can help you with it. So first, what we're dealing with these organic carbons, with these organic compounds, since they're alkanes, alkenes, and alkynes, these are all hydrocarbons, meaning they only have carbons and hydrogens in them. The carbons always form double bonds. I mean, I can't even speak. Not double bonds, 4 bonds. And if all the bonds are single, that's going to be tetrahedral. Therefore, the bond angles are going to be 109.5 with sp3 hybridization. Hydrocarbons are nonpolar. Sometimes they become polar if they have some functional groups on them that create hydrogen bonding or a dipole-dipole. Saturated. To be saturated, what that means is there are no double or triple bonds in the substance. There's only single bonds. So saturated hydrocarbons only contain single C to C bonds, and unsaturated hydrocarbons contain multiple double or triple bonds. When you talk about saturated and unsaturated fats, that's what they're talking about. And we'll talk about later tomorrow. I'll build some molecules and show you why saturated fats are worse than unsaturated in terms of their shape and how they cause clogging in your arteries and stuff like that. So it's pretty cool. So moving on, there's some prefixes that you need to know in order to name alkanes, alkenes, and alkynes. Alkanes specifically are only carbon and hydrogens with all single bonds, only sigma bonding. And their general formula is CnH2n plus 2. It's really helpful to know the general formulas because sometimes you're going to have to draw a structure, and knowing that it's supposed to be an alkane because of the general formula, you'll be like, oh, I don't have to put any double bonds in, and it makes it easier to draw. You need to know the prefixes for all of these all the way out to 10. So if you have a 1, it's meth, 2 carbons, S, 3 carbons, prop, 4 bute, 5 pent, 6 hex, 7 hept, not sept, hept. Geometry is sept. Oct for 8, known for 9, dec for 10. What changes between alkane, alkene, and alkyne is the suffix. Alkanes have an A-N-E ending. What do you think alkenes have? An E-N-E ending. And alkynes have Y-N-E ending. And so depending upon whether or not there's a double bond or a triple bond will dictate whether it's an ene or an ine. Enes have double bonds. Ines have triple bonds. We're only going to worry about substances that have 1 double bond or 1 triple bond. We're not going to do dienes or diines this year. If you take my organic class next year, we get into more of that kind of nomenclature. Okay? One thing I want to show you, which is going to be new this year. Last year, you guys drew out substances like this: CH3, CH2, CH2, CH3. Knowing that carbons always make 4 bonds, you could see that these are all single bonds, right? Because this carbon has 4 because it's attached to that carbon. This has 4 bonds because you got 3 H's and then attached to that carbon. And these being in the center, it's going to be attached and so forth. So this is a total saturated thing. So what would this be called? 4 carbons is butane. So this is butane. Instead of drawing out all these C's and H's, I'm going to start to expect you to draw something called line structures. A line structure of butane looks like this. What that is, 4 carbons, 2, 3. Those are the 4 carbons. And we assume full saturation with hydrogen. So this terminal one is going to have, since this carbon is attached to that carbon, that's 1 bond. The rest are hydrogens. So we assume that this is 3 H's, this is 2 H's, this is 2 H's, and that's 3 H's. Okay? So I want you to be drawing the line structures because A, it's easier for you not to make a mistake. B, it's easier to grade. Okay? You're allowed to put double and triple bonds in the line structures, like that. So if you see that, that's this bond. How many H's are on this carbon? 3. How many H's are on this carbon? 1, because we've got a double bond here and a single bond there. Okay? And then again, 3 H's on that carbon. How many H's on this carbon? 1. All right? So let's go into the rules of naming some of these things. Well, here are the different types. Cycloalkanes, these are hydrocarbons that are in a ring. So because they're in a ring, we lose the +2 on the general structure. Why? Right, because in order for those two ends to attach and make a ring, 1 hydrogen has to be lost on each of those ends. So that's why it's not a +2. Alkenes have, in this class, we only have 1 double bond in them. And alkynes have a triple bond. Because of that, the general formula changes. That double bond is going to make you lose 2 H's. And that triple bond is going to make you lose what? 2 more. So a total of 4 H's from the original alkyne. I didn't mean to move that. I meant to move this. This is crazy. Okay, so let's go ahead and look at rules for naming alkanes, alkenes, and alkynes. Use the generic prefix according to the number of carbons and then add a correct suffix. By number of carbons, I mean number of carbons in the longest parent chain. I call it the parent chain. It's the longest chain. And when we practice, I'll show you what I mean by that. Select the longest continuous carbon chain to dictate the number of carbons for the correct prefix parent chain. All right? Is everyone okay with that? So if I have 10 carbons, it's dec. It's ene if I have a double bond, ine if I have a triple bond, ane if there is no double or triple bond. All right, so if I have this, what would that be called? 1, 2, 3, 4, 5, 6. No double bonds, hexane. Okay? Now, you can have things branching off the parent chain. They're substituent groups, and we call them alkyl groups. And we name them with pretty much the same prefixes, but instead of ending it with ane, we end it with YL. So what the heck do I mean by that? Say I have a group hanging off there. My longest chain is still this hexane, so this is still a hexane. But now I have a 1 carbon group hanging off. 1 is meth, right? Add YL, methyl. So this is what we call a methyl group. We have a methyl group hanging off of what carbon? 1, 2, 3, 4, 5, 6. If I count this way, it's carbon 3. If I count 1, 2, 3, 4, it would be carbon 4. You number the way that gives you the lowest number first. Okay? So this would be a methyl on carbon 3, so we call this 3-methyl-hexane. And we're going to practice this. Don't worry, just listen right now. 3-methyl-hexane. Okay? What would a group of 2 hanging off be called? Ethyl. A group of 3? Propyl. A group of 4? Butyl. And we're not going to get much bigger than that. Okay? And there's some special groups that I want you to know called isopropyl and T-butyl, which are special. We'll talk about in a minute. All right. So this is identify if you have anything coming off of the parent chain. Specify the position of the branch off the parent chain by putting a number in front with the lowest possible, that's as low as possible. So that's what I was saying. Numbering this direction, we got a 3. If we were to number that direction, it would have been a 4. We have to number the way that gives us the lower number. Okay? For multiple substituents that are identical, use di, tri, tetra, etc. So if you had a methyl on carbon 3 and a methyl on carbon 4, you would say 3,4, what? Dimethyl, whatever. Okay? 1,2-dimethyl. If you have 3, 1,1,2, trimethyl, whatever. Okay? So again, we'll practice this. I just want you to go through this list with you. As far as the correct way to write it in pre-AP, they were pretty lenient on you guys, but you really do need to try. Numbers are separated by commas and from letters by dashes. So here we have a comma. between numbers and letters, we put dashes, and you run all of it together. Dichloroethane, it's all one word. 3-methylhexane, all one word. Arrange substituents by name alphabetically regardless of numbers or complexity. What do I mean by that? Well, what I mean by that is, say you have, let me make a really long parent chain so I don't get any problems. So we have this. Okay, how long is our chain? 1, 2, 3, 4, 5, 6, 7, 8, 9. So what's the base name of this? No name, right? Now, what's hanging off of no name? We've got on carbon 3, other direction, it's much higher, correct? So I'm going from left to right. On carbon 3, we have what kind of group? A methyl. And what do we have on 4? An ethyl on 4. You list these alphabetically, not by number. So it would be 4-ethyl, 3-methyl, no name. Because we're listing them alphabetically, regardless of number or complexity. Okay? So this would be 4-ethyl, 3-methyl, no name. Now the last little bit, for alkenes and alkynes, when we start getting double bonds involved, let me erase this so I can talk about this. The most important number is going to be dictated by where the double bond or triple bond is. So say we have a double bond there. Okay? That double bond, you have to tell whoever is looking at this compound where the double bond is, okay, when we name it. So this has how many carbons in the long chain? 1, 2, 3, 4, 5, 6. So what's the base name of this? It's a hexene. But I could have a hexene with a double bond here, or a double bond here, or a double bond there. So I need to indicate where that double bond is by numbering the carbon it's after. So where is this double bond? After carbon, not 5 because that's too high, going this way. So we're going to go that direction. So it's after carbon 1. This is called 1-hexene. Where the placement of the double bond or triple bond is takes precedence over any group hanging off of it. So let's say I had a methyl group here. I determine the direction I'm numbering these carbons based on making the double or triple bond lowest. This means I have to number this direction. When I number that direction, I now have the number that that methyl group is on. And I can't change direction. I can't say, oh, it's 1-hexene, but then I go this direction and say, oh, but that methyl's on 2. Nuh-uh. You first determine where the double bond is and place that after the lowest number and then name from there. So what is this called? 5-methyl, 1-hexene. So anytime you have a double or triple bond, you have to indicate where that double bond is by putting it on the lowest number or after the lowest carbon. All ready to practice? All right, turn to the page in your notes that says Basic Organic Nomenclature. We're going to go through structural isomers and stuff in a bit. It's quite far in the packet. What page is that? Page 7 in your packet. Okay, so let's look at this. Let's start out with this one first because I don't want to kill you just yet. All right, so the first is to determine the longest chain. The particular program I used, and I figured out how to fix it now, and I am not in the mood to go back and redraw all these, put my carbons that are terminal in there. I'm okay with you just drawing things like this without writing CH3 on the backside of any terminal carbon. It's not necessary. But just know that that's this particular computer program. So it's okay to draw it just like I drew it. All right, so first we have to find the longest chain. Where is that? 1, 2, 3, 4? No. 1, 2, 3, 4, 5, 6. That looks like the longest chain to me, right? 1, 2, 3, 4, 5, 6. So what's the name of this? The base name? Hexane, because there's no double bonds. And if we go from left to right, 1, 2, 3 carbon, We go the other way. 1, 2, 3, 4. Which one do we choose? 3. So what's this called? 3-methyl, attach it, hexane. Okay, what about this one? What's our longest chain? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Nope. 1, 2, 3, 4, 5, 6, 7. Either one will work. So I'm just going to go like this. There's my longest chain. I like, when I first started learning this myself, I remember darkening it so I can see that long chain. So what direction should I number? Left to right or right to left? What? Left to right or right to left? Left to right. So that's carbon 2 and that's carbon 4. All right, so knowing that we have 1, 2, 3, 4, 5, 6, 7. So that's what base name? Heptane, okay. And how do I, number 2, this is called a what? Methyl. And 4 is 1, 2, ethyl. All right, what do I do? Yes, 4 ethyl, 2 methyl, and then I'm running out of room, but you're supposed to attach it, 2 methyl, what? Heptane. Okay. Okay, we have to, I'm looking at this one because I want to show you something. This is a weird one. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. If I go that way, I have 6 as well. Which one do I choose? There's an IUPAC rule. Why, is there 7 somewhere? I don't think so. There's an IUPAC rule that says if you have the option for the same number of carbons in a chain, choose the option that gives you the most substituent groups, the most things hanging off of it. Going straight up this way, how many things do we have hanging off? 1 big fat group. Going this way, we have the same number of carbons, but now we have 2 groups. So you choose that direction. That's pretty tricky. You're not going to see that. I'm not going to do that to you very often. I won't do that. I'm just telling you right now, I won't do that to you on the test. 1, 2, 3, 4, 5, 6. So what's the base name? Hexane. All right. So I know that the base name is hexane. Which way am I going to number? This ethyl group is going to have what number on it? 3, and the methyl will have 2. So what is this one called? 3-ethyl, 2-methyl-hexane. 3-ethyl, 2-methyl-hexane. Okay, let's look at this next one because it's going to address another issue. What's our longest chain? 1, 2, 3, 4, 5 looks longest. So what's it called? Pentane. All right. What do I have hanging off of it? What's this? A methyl and a methyl. And carbons what? 2 and 3. I don't say 2-methyl, 3-methyl. There was that rule that said when you have the same functional group, you use di, tri, etc. So what do? I say 2, 3 dimethylpentane. Now, if you have groups can hang off the same carbon. Technically, this could be moved over to here. If that's the case, you'd say 3,3 dimethyl. Because if you see di, you need 2 numbers. If you see tri, you need 3 numbers. Okay. What else? Pick one that looks like it's interesting. Well, I don't have to do all of these. Upper right? Okay. So our longest chain, 1, 2, 3, 4. This is carbon what? Carbon 2 from this direction, because it will be lower than carbon 3. So it's a butane. What kind of butane? A dimethyl. right? So what's it called? 2,2-dimethylbutane. I think this is pretty much the same thing. 1, 2, 3. Yeah, this is actually the name of both of these. That was good choices. Yeah, this one's tough. 1, 2, 3, 4, 5, 6. What's that called? Hexane. And this one, 1, 2, 3, 4, 5, 6, 7. What's that called? 4-methylheptane. You still hate this, Garrett? Okay, good. It looks bad. It's not that bad. Okay, now we're getting into some good ones here. What's this one? Yep. Methane. What about this one? Ethine. Okay, looking at this next one, that double bond has to indicate the direction of the numbering. Okay, so that double bond is either after carbon 2 going this way or carbon 2 going that way. So either way, it's going to be carbon 2. But which way do you think we're going to number based on the fact we have that methyl group? Left to right. So this is carbon 2 for us, okay? So the base name of this is 2 what? 1, 2, 3, 4. Butene. Remember, you have to have this 2. That tells us where that double bond is. And now we name where the the alkyl group is. So it's 2-methyl 2-butene. What's this one called? 1-propene. Do I need the 1? Why not? There's no other way. If I had this double bond here instead, wouldn't it still be after carbon 1? And people ask, is that wrong? Not really. It's just not the right name, though. It's like me calling you Garrett. Beta, beta. Okay? It's like saying your first name twice. It's just not necessary. Okay, let's do 3 groups here in the long chain. So 1, 2, 3, 4, 5, 6, 7. Okay, so that's going to be a heptane. And what do I have hanging off of it? A methyl, a methyl, and a methyl. What carbon number is this one with the 2 methyls on it? 3, and this one is then 5. So what's this called? 3,3,5 trimethylheptane. Okay, let's do this one real quick. 1, 2, 3, 4, 5, 6. It's kind of the same concept, except this is carbon 2, 3, and 4. So what's this called? Perfect. 2, 3, 4 trimethylhexane. Okay. What's this one called real quick? One, 2, 3, 4. What kind of butene, though? Please don't forget that. Okay, let's look at this guy. He's a cyclo. He's a cyclopentane. If I don't have any functional groups hanging off or any alkyl groups, and I only have, and it's not pentene, I don't need to put a 1 there. Why not? It's a circle. Now, let's say I were to take this and ramp it up a little bit and actually throw a methyl group on there. I would have to number them. so I could know the relationship between each other. So what we need to know is this needs to be after carbon 1. So either this will be carbon 1 and we'll number that way, or this will be carbon 1 and we'll number that way. Whichever way gets us a lower number on this methyl is the way we're going to go. So if we go this way, this is 1, 2, 3, 4. If we go this way, it's 1, 2, 3. So we're going to go this way and make it a 3. Okay? Sarah's perplexed. Is it 4? Did I miscount? Let me do it again. Let's do it with different colors. So this is 1. I'm going this way. 1. I had it here, right? 1, 2, 3, 4 that way. If I had it here, this would be 1. 1, 2, 3. Yeah, it is. My bad. Okay, so it's regardless of each way you go, it's going to be 4. So what would that be called? 4-methyl. And really, you still don't need to put the 1 because it's always going to be after the 1. 4-methyl cyclo. And if you do it, I'm not going to freak out. Pentene. Not pentane, pentene. Oh, it's not a dash, yeah. 4-methylcyclopentene. T-H-Y. Hold on. Let me rewrite it totally. 4. Okay. Let me just go to the next one and see if there's any more interesting ones. Okay, this is an introduction to a new group, and I'm going to introduce you to 2 new groups that are special. Up to this point, the alkyl groups we've been talking about have been methyl, which is 1 thing hanging off. This is the long chain. Or ethyl, which is 2 things hanging off. Okay, these are all linear. If we had propyl, it would be 3 things hanging off, attached linearly. Okay, so this is methyl, ethyl, and propyl. But the world doesn't work this way all the time. Okay, sometimes you'll get groups that look a little bit different. One of these groups is called isopropyl, and I want you to know this one. It looks like a Y. Why propyl? Because there are still 3 carbons in the group attached. Notice here there's 3, but they're all in a line. Here there's 3, but they're attached. And iso, you're going to learn in organic, it has to do with the attachment on the second carbon, the one nearest the back. It's a special thing. I'm only making you memorize two this year, so don't worry about it. Isopropyl. Propyl. Okay, that's your first group that's a little bit different. And then the next group looks like this. How many are in this one? 4. So what do you think part of the name is? Butyl. What is that shape? T. It's called T-butyl, or also known as tert-butyl, and I'll take either. So that's what this group is. Do you see how it's a T? And there's 4 carbons in that T? That's tert-butyl. The reason this is not, if we look at this as the longest chain, I don't know if it is, but 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and it's not. Dang gummit. If that were the longest chain, let's make it so. There. That's the longest chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll stop at 10 because that's all I told you to know. So this would be 1, 2, 3, 4, 5, which is in the middle. So it would be 5 T-butyl what? Decane. Another thing I want to point out to you, which is important, a lot of people want to call this Hexane, but it's not. Why not? There's a carbon here and here. Okay? Ethine would look like this. Right? So just keep that in mind. So what is this called then? 2-butane. Okay. It is crucial you do your homework from the textbook and practice. You might run into, because I'm not going as far as I usually do in this day, you might run into some of these at the bottom of the page that you see, those cyclos, that we're going to cover those tomorrow and do functional groups tomorrow all in one day. This is all I'm going to have time for in my other classes today. So you have got to practice this stuff.